Picking up where we left off yesterday with our conditional probability, right? We had just finished talking about the probability of whether black and van is independent or dependent. Okay, came up with the dependent answer. And then we have a second problem based on the same frequency table. And this one we're going to talk about, what is it, red cars? Let R represent whether the vehicle is red, and C represent the vehicle is a car. Are the events, R and C, independent or dependent? And explain. Which, in my opinion, if you're putting your work and showing your work like what we did in the previous problem, you are explaining. So, go back and look at the previous problem from yesterday. Do you remember what to do?
Wait. Okay. I did. Okay. All right. Hold on. Coming back.
Yesterday we started by finding
Probability of B and B.
Well, so black given it's a van, yes?
Yeah.
So, and then after we found that, we also checked van given it's black. We need to check both here. So let's start, and it doesn't matter which one you start with, because if they work out to be independent, we need to do both. So I'm going to do the probability. There's no V here. It's not a van. Red given it's a car. So probability of R given C. So probability of red given it's a car. Okay, remind me, what's the fraction we set up there? On top, we're going to put what probability?
R and C.
R and C, yes? So you're just putting the number of red cars up top, yes? Divided by, what goes on bottom? The probability of C, whatever your condition is, right? So probability of it being a car. And again, remember, I was kind of shortcutting this, not actually doing the probability, just looking at the total numbers. So how many vehicles R and C, red and cars? What do we have there? 5. Out of
22.
probability of being a car. How many cars are there?
22. 11.
I'm going with 11.
Yep.
So probability of a red vehicle, probability of a vehicle being red given it's a car is 5/11. What do we need to check? If it's independent, this one up here, the example shows probability of B given A has to equal probability of B. So ours is probability of R given C. What do we need to check and see if it's equal to? Probability of the first piece, so R. What is the probability of a vehicle being red? How many red vehicles do we have?
7.
7 red out of 22. Okay. What can we conclude at this point? Dependent? Because what we do know right now is that the probability of R given C does not equal the probability of R. Now, should we take the easy route and just stop there?
Yes.
I'm willing to go for it this time. Yesterday I wasn't willing to go for it. It was our first example. I kind of wanted to make sure you guys saw both pieces. Okay, practice a little bit. But this one, we already found one half of this saying they are not independent, so they're going to be dependent. That's my explanation right here. So I can simply say events R and C are dependent. Okay? If you wanted more proof, you could flip this around and do the other way. Probability that a vehicle is a car given it is red. Okay. And remember, this is our proof or our test for independence. So In homework, if you're asked to test something for independence, this is what we're doing. One more example with this. If you look down at that bottom chart, the table shows data for the junior class at a high school. A student from the junior class is selected at random. Let G be the event the student is a girl, and F be the event the student is taking French. Are the events G and F independent or dependent? Okay. What am I going to suggest we do? We find one of our conditional probabilities, yes. I don't care which we find first, because if we have success on the first set, I'm going to say we need to find the second set. So I'm going to start with probability that the student is a girl, given they are taking French. You know your setup at this point, yes? On top, it's going to be the amount of girls in French. On bottom, it's going to be the amount of total taking French. How many girls in French do we have?
I'm in Thailand. 45.
45.
Yeah. I played for one day.
Probability, or how many students taking, or how many students taking French?
75.
75.
Layton, you're doing pretty good. You understand this?
What do we know about 45 over 75?
Well, it can reduce.
Reduce to what?
It doesn't tell you.
Well, if you do it,
It's 9 and
3/5. Right.
yeah.
Okay. I'm with you on the 9 and 15 part if you just divide them both by 5, right? But then when you divide by 5, you end up at 9 over 15, which can then divide by 3. And so
What?
we are at 3/5.
3/5.
Okay? What do I need to compare this to?
3/5.
This was probability of a girl, probability that the student is a girl, given they are taking French. And we need to compare that and see if it's equal to what?
French.
Go back up and look.
The student's taking French.
Uh-huh.
Yeah.
It's whatever your first piece there is. Okay? So our first piece is a girl. So we're comparing to probability that a student is a girl. What do we have on probability a student is a girl?
45 out of, is that 500? No.
Augie, look at this G that I wrote.
Oh, wait, yeah.
It looks
my
horrible.
fault. 300 out of, yeah.
Okay. Total girls is 300 out of 500 total students. What do you know about 300 over 500?
I think that's 3/5.
Okay. So, what do I know so far?
They're equal.
They're equal.
We
It's
know.
looking to be independent. Am I ready to 100% make that claim, though? No.
Why not?
If it's independent, it has to work both ways.
What does?
The probability. So we checked one conditional. Probability the student is a girl, given they're taking French. We need to reverse that also. So like right now, what I know, okay, so that is true. We've got to reverse the situation and make sure it works the other way too. So now I'm going to check probability a student is in French, given they are a girl. Okay, so check both ways. So numerator, come on guys, focus, is still going to be both, right? Girls and that are also in French, or in other words, students that are French or in French and girls, divided by?
Probability that they're French.
No,
No,
probability that,
girl.
go for the condition, probability that they are a girl.
Over.
Okay, so how many students are taking French and a girl?
French girl.
45.
Still 45. How many students are girls?
300.
300. What about 45 over
That
300?
is not three fifths.
That ain't it. That's like a little under.
So can I just say I'm done? 'Cause I-
No, we're not done.
But it's not gonna be three fifths.
It doesn't have to equal
It
three
doesn't.
fifths.
It has to just equal. It's in the same.
We have to
sense,
finish the rest of the problem.
You know. That,
So I need to know what this
Up there.
reduces to.
Well, it's
and
obviously
then the
all
bottom
two.
are the same.
Come on, guys. Get serious. Cut the extra chatter.
320.
Top and bottom divide by 5s at least, right? What are you down to?
320.
3/20th?
320.
Sounds familiar. Which means they both divide by 15 is what actually happens.
Yeah, I mean
Okay.
you could have went 5 and worked your way down.
Now, I'm not comparing this to the first round. I'm comparing this, probably a student is taking French given they are a girl. What are we comparing this to? Probably that a student is
And
taking French.
take it for.
So what is the probability that a student is taking French?
Well, there's
75
over 400. Yeah,
75.
500. Which
75 out of 500. I see quarters here. I see I can divide by 25.
Oh.
I know 75 divided by 25 is 3.
Oh.
How many 25s in 500?
20.
What did we just figure out here?
They're independent.
Okay. Probably a student is French, taking French, given they are a girl, equals probably the student is taking French. Because it worked both ways, we can say events F and G are independent.
Imagine you do the whole problem through the last little bit. Doesn't happen. And you're like, you did all that. Yeah. It's like I'm tired right now.
Okay, guys. Make sure you have everything you need from this page. We have 2 sections on the back page to talk about, 2 different topics, I guess.
That's it. Done then. Then we're done.
Okay. As you look at the next page, it talks about applying the conditional probability formula. So using that formula there that we've been using. A band's marketing agent conducted a survey to determine how many high school fans the band has. What is the probability that a surveyed student plans to attend the band's concert and is a fan of the group? Now, you have a chart of gathered information here, yes? So, if you start looking through that, okay, the first group is students who plan to attend the concert. And of the students that plan to attend the concert, 70% plan to attend, and 80% of the students who plan to attend are fans of the band. Okay? Then there's also students who do not plan to attend. 30% of the students do not plan to attend, which should make sense, right? Because up top it said 70% plan to attend, 30% do not plan to attend. Of the ones that do not plan to attend, 25% are fans of the band. Okay. Now, go back to what our question was. Our question was a probability that a surveyed student plans to attend the band's concert and is a fan of the group? Okay. Well, we have to be careful here. They want of the students surveyed. This is broken into 2 groups here. 70% of these students that plan to attend, 80% are fans here. And, huh? So we want to know the ones that attend, what probability that the surveyed students plan to attend the band and are a fan. So
10%.
of the 100%,
Yes, 10% are fans, but they're not going.
Mm-mm.
Yeah.
Mm-mm. I'm saying, So
Okay.
So CJ.
So, okay. Here's what, notice the heading up here was using our conditional probability formula, right? And that's the probability of B given A is that fraction probability of B and A over probability of A, right? We're going to use that idea. Okay, so that formula we've been using since the first moment we started this lesson. Now, with that in mind, we're not talking about A and B, we're talking about what? Attending and fans, yes? So ultimately, when it talks about attending and fans, we're talking about probably that a student is a fan given they are attending the concert. That's ultimately the question we're going for here. And so I'm going to set this up because I want you to see the formula. The group we need to talk about is the probability that a student is a fan given they plan to attend the concert. If you're finding this, okay, on top it's going to be the probability of
Students and fans, or fans and attendance.
fans and attending. The denominator is going to be probability of
Attendance, or
that someone is attending.
Yeah.
Okay? Now, if you go and look at what is provided both versus what we have to find, we want the probability that a surveyed student plans to attend and is a fan. What we are actually needing to find is this right here. Okay? We actually have this information provided. We're being asked to find that. And so if you think about this like a formula, right? If I'm trying to find this on top, what do I need to do with this probability of attendance here? We're going to have to divide it over there, yes? And debating it. Would it be easier if I fill the numbers in first? Because I was going to multiply it over, but now that I think about it, second thought, let's fill in numbers. Okay? So, with that in mind, trying to figure out the best way to teach this. That's what it's coming down to. Do we know probability that a student is a fan given they're going to attend?
student is a fan, and 80%.
That is 80%. Now, normally when we put numbers in a formula, we don't use them in a percent form. We use them as a decimal. Oops, wrong place. So that's going to go over there. Okay, because we were provided with that information. Now, do we know the probability that a student is a fan and attending? We don't. That's what we're trying to find. So I'm just going to leave that as probability of fan and attending. Do we have the probability of students that are going to attend? That is the
70.
70%. 70% is a decimal. 0.7, or in other words, 0.70. Now that you see numbers in there, do you see how to do the math to fill it in? If we're trying to find the probability that a student is a fan and attends, we're going to, since it's currently dividing by 0.7, we're going to multiply that 0.7 over. Yes?
Don't we know how many? Don't we know fan and attend?
We know, okay, so what we're trying to find here is out of the whole student population. This is 80% of those attending the concert.
Oh.
We're trying to find of all of them. Does that make sense? There's a lot of wording here. I'm struggling with how to keep all the wording straight.
So I was looking at that and
I know. I'm struggling with how to keep all the wording straight. I'm working to figure out the best way to teach this as I go too. So now you do see this though, right? It's divided by 0.7. We're going to multiply. The probability of a fan and attending is going to be equal to 0.8 times 0.7. What is 0.8 times 0.7? 0.56. What do you know about 0.56? 56%. Okay, so when we talk about this, this is probability that a surveyed student plans to attend the band's concert and is a fan of the group. Okay.
Okay.
Okay. Now, I do have another one down here to practice with because I knew that first one would be rough getting all the pieces through. I feel like there's got to be a better way I could have set that up, but I'm not sure what it is quite yet. Gonna have to work on a better way to set that up. It's a little less confusing. Because I think we're a little confused right now, aren't we?
Yeah.
I'll work on it. Okay. Look at the second piece. What is the probability that a surveyed student plans to attend but is not a fan of the group? Okay. So remember, we've got two sets of surveyed students. These are all go together, right? So probability that a surveyed student plans to attend but is not a fan of the group. So when I set this up, plans to attend but is not a fan of the group. So I'm going to say, what's the probability of not being a fan given they plan to attend? Okay, those are the two pieces we're looking at here. Probability that they are not a fan given that they plan to attend the concert. Set up our formula like we have been. On top, it's both, right? Probability of not a fan and attending divided by probability of the condition, right? Go back to that original formula. Okay. Same thing as last time. We are trying to fill in what we do know. What do we know? Probability of not being a fan given you are attending. Thoughts on that one? Read what you have and think about it. Probability of not being a fan given you are attending the concert. Why 20? I don't see a 20 up here. Yeah. Right here, 80% of the students who plan to attend are fans of the band. There's a lot of wording here, I know. So what does that mean? 100 minus 80, right? 100 minus 80 is going to be 20%. So that's your piece that's going to go right here, the 0.2. Again, like last time, we're trying to find that top piece. Probability that they are not a fan and attending. Divided by probability that a student is attending. Probability a student is attending. That's stated right there as 70%, which is going to be the 0.7. How do we do the math here? Again, it was dividing, so we're going to multiply. Notice it's going to be multiplying when we do these. So, probability of not being a fan and attending of the entire group is going to be 0.2 times 0.7. What is 0.2 times 0.7? 0.14, which is 14%. Okay. I'm just feeling I may have some homework questions on those to answer. We'll see. We definitely need to figure out a little bit better way to teach that, but. And I'm guessing we'll find some shortcuts as we go about this. Okay, we're just gonna have to work. I'm gonna have to work to figure out the better shortcuts here. Okay,
This is impossible.
it's not impossible.
Very impossible.
Nope, not impossible.
Who even thinks of this?
Okay, let's move on to the other section, which is going to be less impossible then. Okay,
There we go.
I have confidence this next section will be better.
I'm at not
Okay.
Impossible. You're up here going with this impossible crap.
Last piece, using conditional probability to make a decision. Notice, a marketer is looking at mobile phone statistics to help plan an online advertising campaign. She wants to find out which of her company's products is most likely to be purchased after a related search, after a search for that product on a mobile phone. Okay? So the idea is if someone does an initial search, what's the chances they're going to then again going to search that same product again later and then buy it? Okay? After their initial search. So basically, is the advertising doing its job and getting someone to come back and say, oh, yep, I'm going to come back and buy that. Okay? Now, we want to know which product is better. Which product has a better chance, W, X, Y, or Z? It said use conditional probability to do this, yes? Notice the two columns here. Okay? If we're talking about trying to find the probability that someone's going to buy something, given that they previously searched it, here, I'm going to write it like this so you can see. Probably someone's going to buy something, given they previously searched it. Well, think about what your formula would have to be. Conditional probability formula, what we've been setting up the whole time. What goes on top?
Answer.
Both together, right?
Yeah.
So probability of B and S. What goes on bottom?
Search.
Probability of S, search. What do we have in our two columns?
Search.
We have search and search and buy.
Yeah.
Do we have the pieces we need for that formula?
Nope. I reckon we do.
Okay. So basically, we can set up probability of B and S divided by probability of S on each of these four products and grab the calculators and do the math. Is that a little bit easier than last set?
Yeah.
Okay, maybe a lot easier?
Yeah. I don't know what was going on last time.
Yeah.
I was on the
So W. What are we going to divide for W?
You're going to do 0.16. Yeah, 0.16 over 0.4.
Okay, take the percents, turn them into decimals. Those are our probabilities. So we have 16% and 46%. Grab the calculator, divide it, and we are going to take that decimal and turn it into a, did I turn them into a percent? I have them to a percent to one decimal place. So when you multiply this on the calculator, I have 0.3478 written down. Is that maybe just the first four and I rounded? Okay, but if we change that to a percent, move it over 2, it becomes what? 34 point, if I just went one decimal place. So that is 34.8%. you do that for the next 3? Given a calculator, it's an easy task, right? So after W is X. So for X, search and buy divided by search. When you divide 0.14 divided by 0.32, you get, I have 0.4375 written down, which is approximately 43.8%. Y, search and buy is 12%. Divided by searching, 35%. 1200ths divided by 3500ths. .3428, which as a percent, 34.3%. And product Z. Search and buy is 15% divided by 40%. (15% divided by 40%? I don't think I had to round this one. This was probably exact. Okay. So, I got my data up there. You guys got yours data?
Yes.
Question was, which of the company's products is most likely to be purchased after a related search and then search and buy?
X.
Product X?
Yeah.
Okay. Product X has the highest probability. So product X, and the reason is, has the highest probability. Proof is in the numbers there, yes? Okay. Next example is very similar, isn't it? Have you read it? Did you look at it? The same marketer also has data from desktop computers. Which product is most likely to be purchased after a related search? So last time it was phones, this time it is computers. Can you do the same thing for JK, L&M?
Yes.
Okay. Again, it's going to be the probability that they buy something given they had a previous related search. So in order to do that, it's going to be probability of buy and search on top divided by probability of searching on bottom. So let's see. J. (10% divided by 35% is 0.2857. 28.6%. K. 9% divided by 28%. 9% divided by 28%. 0.3214 or 32.1%. L. 8% divided by 26%. Which is 0.3077. or in other words, 30.8%. And M, 5% divided by 24%. 0.2083, which would round to be 20.8%. Which computer is most likely to be purchased? What was it? Okay. So here we know that product K has the highest, and you can even use the word conditional probability. Okay. Your homework to do for tomorrow is 12.2 in Savas.